So GPIO is a library for using the GPIO pins, the general purpose input-output pins on the Pi, which allow you to connect it up to the real world. Prior to GPIO 0, all the libraries for any different language were very low level, so it was all about sort of pin manipulation, turning pins high, turning pins low. What I did was abstracted that out into a simple interface to create a friendly API so that your code becomes more readable and things become more obvious about how you achieve things in certain projects with your Pi. I want to start by talking about the sort of multi-paradigm approach that we have in GPIO 0. So this is one example, which is a good sort of way to get started. This is the code I would write with if I was working with a child or with a teacher who's new to this, is this kind of programming style. So it's just procedural, it's going down, so it's going from the top to the bottom, there's a loop there, and it's using an if statement, so we create our LED, create our button, and we say while true, if the button's pressed, turn the LED on, else turn it off, which means your button controls your LED. It's a very simple programming concept. Another way of achieving the same thing in slightly fewer lines is to use an event-driven approach. So this has its benefits as well, but it's apart from being shorter. So here we attach events to the attach function calls to the events of the button being pressed and being released. So on the event of it being pressed, it does one thing, it turns the LED on. When it's released, it runs another event and does something else, turns the LED off. So you can assign different functions to that. These are the built-in ones that are part of the library. And there's a third approach, which is a more advanced concept. But essentially, in that one line, I've done exactly the same thing I did in the previous two examples. Here, this is what we call declarative programming. So rather than running a loop with 6 lines of code or something saying, keep checking the state of the button and keep updating it, the LED should either be on or off according to this, you're just declaring in one line how the LED should behave according to the button. Now, I'll explain this in more detail later on, but I just wanted to explain that sort of idea of the different ways you can approach learning different things with taking that step towards the more advanced approaches in GPIO 0. So we have great support for all these different devices, so all the sort of regular components you find in the camjam kits and different electronics kits and things. We have a lot of support for various different things, all the way from LEDs and buttons and buzzers to basic sensors, add-on boards, motors, robots, servos, and all sorts of things. We have this huge device hierarchy. If you have a look at the documentation, you can read up on how the implementation shares all the code across the code base. So this source value thing that I was talking about, the way it works is that you can use .value to set to read a device. So every device has a .value, whether it's an input or an output. So here we are, we create an instance of a PWM LED, which is an LED with variable brightness. So initially we have a look at that, and the value of the LED is 0, so it's switched off. We run LED.on, so run the on method, it turns the LED on, and now we look at the value and it's set to 1. We can also set that to 0, or set that to 1, or set that to anything in between, and it achieves the same thing. So you set the brightness from 0 to 1. So if we have an LED, a PWM LED, and a potentiometer, so a dial, you can dial from one side to the other. You might want to say, I want the LED value to be exactly whatever the potentiometer is. So I can say, set the current value, set the LED brightness to whatever the current value of the potentiometer is, which is also 0 to 1. As you dial it from one side to the other, it goes from 0 to 1. And then you might end up writing code like this, to say, keep updating the LED brightness according to whatever the potentiometer is. And that's what led towards the creation of this source values component. So rather than having to sit there in a loop constantly updating, what we could do is we can look at the output device and the input device and just pass in values from the output device, from the input device into the output device. So that they are now, with this code, set the LED source to the button values, or set the LED source to the potentiometer values. They are now connected, and in the background, constantly be updating itself and setting its value to whatever the other device is. Which is really just a really neat way of telling the devices that they should be connected together. You can also process the value as it goes from the input device. You can process it with a function in between and pass it into source. You can either write your own function that does that, or we have a set of source tools, which you import from the GPIO0.tools part of the library. And you can there are all these common tools for manipulating the sort of data sources as they go from one device to the next. So negated is a function which takes the device, and if it's true, it turns it to false. If it's false, it turns it to true. So now we've set the LED source to negated button values. So the LED is on when the button is not pressed, and it's off when the button is pressed. So it's the opposite behavior as described before. There are also other source tools that don't just take one input, they take multiple inputs. So you can put one of the source tools in between, which, for instance, we have two buttons and an LED. And I say the LED should be on if all of the buttons in this list are high. So it's essentially this is like an AND gate for LEDs. So the LED's behavior is defined in one line that it should match the AND of those two input devices. There's some really interesting things you can do with that. We also support multiple backends in GPIO0. So originally, GPIO0 was just a simple abstraction on top of Ben's library. Ben's sitting in the front row here. GPIO. So it was just a nice API sitting on top of that, and GPIO is doing all the work underneath. We ended up swapping out, making it so you can swap out a different GPIO backend library, the bit that actually does the pin manipulation. So we have support for a library called GPIO. There's another one called GPIO, which has some really cool features. We have a native pin implementation written in Python, which is kind of quite limited in its functionality. You can't do pins and things like that. It's quite experimental, but it's good sort of fallback if you haven't got another library available. And we also have a mock pin interface, so you can run your code on a PC that, and you're not actually manipulating pins. You're running the exact same code, and the devices behave as if they're really there. It's just a way of testing that your code is some sound. So here's an example of how you might use mock pin. So if you launch your Python interpreter, whether it's idle or Python shell or IPython or something else, with this environment variable set, you set the GPIO pin factory to mock pin, and then launch your environment. Here's an example. We import LED, create an LED, tell it to blink, and then if you inspect the value, you can see that it's changing in the background. Every time you look at it, it'll be something different. And what you can do here is, so here I've got an LED and a button. These are created on mock pins. And I've connected the LED to the button, so the LED should be on when the button is pressed. But because this is a mock button, I don't have a way of physically pressing that button. So what I do is I create an instance of a mock pin on that same pin, so I actually have control of that mock pin. And then I can drive that pin high or low. So because it's a button, it's pulled up by default, so it's originally high. And if I drive that pin low, that means the button is being pressed. Then I can have a look at my LED value, and you can see that the LED has now come on because essentially my button is being pressed. It's really good for testing. We actually use this to test that the library itself, that it functions the way it's supposed to. So one of the libraries that I mentioned that we support is GPIO. This allows you to do remote control your GPIO from another Pi or from a PC. So you can write GPIO0 code on your PC running Windows, Mac, Linux, Pixel, or even actually do this from another Raspberry Pi and control not just your GPIO pins, but the GPIO pins of that other Pi on the network. There's a few different ways you can do this. One of the ways here is, rather than just passing in a number to the LED constructor saying, put me an LED on pin 17. You say, for instance, pin 22 on this IP address. Make you an instance of an LED that belongs on you, that's running on your PC, on your Python. It's not doing it over SSH. Your Python is running, it's got that object. You can control exactly the same way. But the actual GPIO calls, rather than writing into your computer's memory and changing the pin state locally, you might not have any GPIO pins, which would be on a PC. It's sending a socket command over the network to tell the daemon running on the Pi that it should turn pin 22 on. It's a really cool way of controlling multiple devices at once, or running your code on your computer and controlling your Pi over the network. Another way of doing it is to use another environment variable. So here I've used Pi GPIO address equals this, and that essentially sets up the default pin behavior to be a remote pin on that IP address. So here I'm just using exactly the same code, but if I change the IP address and ran it again, it would run the same code but on a different Pi. And you can use a manipulation of those, so you can say, use this version to say what my default is, but then change halfway through and say create an LED on this particular IP address as well. There's a lot of stuff in GPIO 0 that people don't know about, which is why I'm sort of giving this talk. So as well as all the obvious stuff that it's easier to flash an LED and you can do this stuff with connecting devices together. One of the other things is the internal devices we provide. These are classes that you create instances of, which act and behave like a GPIO device, like an LED, like a button. But they're not really GPIO devices. They don't have any, they're not connected to pins, they're not real GPIO devices, but they can plug into other devices in the same way. You can use a button as an input, you can use the time of day as your input. So here are 3 examples of 3 internal devices we have. So this is like what I have set up at home. I've got a little tortoise that lives in this little tortoise table. I have an energy connected to it, which is built into GPIO 0. And what I do is declare daytime to be a time of day object that's active between 8 AM and 8 PM. So the same way a button is active when it's pressed, this object is active during that time of day. It will go inactive when it hits 8 o'clock. And then I've said the lamp source should equal the daytime values, which means the lamp should be on when the daytime object is active. So the lamp should be on during the daytime period I've described, and then it should go off otherwise. Another internal device is called ping server. So if I create a green LED and a red LED, and I create an instance of ping server on google.com, I set the source delay, which is a way of saying it should only keep checking for a new value every 60 seconds. Usually it's very fast, so that you can do your LED button example, that kind of thing. It should be constantly updating and being very fast. This one, I only want to check it every minute. So I set the green source to be Google values, which means the green should be on if Google is available. My ping to Google is successful. And then the red should be on if the green is not on. So it just means one or the other will be on, telling you whether your internet is on. Your internet is working. The other one is CPU temperature. So we have another GPIO collection class called LED bar graph, which was contributed by Martin O'Hanlon, where you have an array of LEDs, and the value of that LED bar graph object is somewhere between 0 and 1. And rather than just being the brightness of a single LED, it's how many of the LEDs available should be switched on. So if that is set to 1, then they'll all be on. If it's set to half of them will be on. If it's set to 0, none of them will be on. So you can pass in a number into your LED bar graph and it will line them up according to whatever you passed in. Here I've set CPU temperature, set that up so that its 0 value is when the temperature is at 50, and its 1 value, so its maximum value, is when the temperature is 90. So whenever you read the value of your CPU temperature, it will be some number between 0 and 1 according to wherever the temperature lies on that scale. Then I've said the source of the LED bar graph should equal CPU values, which means as the CPU temperature rises, the more LEDs get lit up. And if you hit 90, temperature of 90, all of the LEDs will be on. There's only those 3 internal devices currently, but it's very easy to make your own. So I actually, there's a pull request pending, one that I added in recently that was for the load average of your Pi. So you can say do the exact same thing based on your Pi's load average. So how much CPU activity is there on the Pi? You can say light up all the LEDs. You can open up Mathematica and see it sort of start spinning into control and do stuff in Minecraft and see the LEDs light up as the CPU starts being more active. And as I say, you can actually write your own. It's very simple. Just take one of the existing templates and change how it determines what the value should be, and you can just pass that into another device. I've been doing a lot of demos recently with a library called GUI0, which is a zero boilerplate wrapper around the Tinker library for creating GUIs. Actually, these 2 examples aren't using GPIO0, they're doing other things, but it's the same kind of idea, that you can create a little GUI on screen to control your GPIO devices, which is quite cool, but it's very easy to get started. I definitely recommend you take a look at that. So if you were here for Adam's talk earlier, he was talking about the release of Pixel x86, so you can install Pixel, our operating system, on your PC. The great thing about that related to GPIO0 is that because it comes with all the software that you get with Raspbian on a Raspberry Pi, you have GPIO0 there, and you can use either mock pin, of course, or PyGPIO remote pins. So you can control a Raspberry Pi on the network from your PC using Pixel. Of course, you can do this in Windows, Mac, Linux, whatever else, but you have to install GPIO0 and PyGPIO, whereas because you've got Pixel, it has everything that you need already there, which is really fun. This is a really good way of things like schools and code clubs. If they don't have the means to plug in a Raspberry Pi and a full setup and the whole mouse, keyboard, and everything around the Pi, they can just use their existing PC setup, have their Pi 0 plugged in over USB or something like that, and really easily get to join in with the physical computing stuff and use the Raspberry Pi resources and things like that. It's a really cool way, and I'd love to see people using this for that kind of thing. So if you want to take a look at GPIO0 in more depth, you can have a look on GitHub, have a look at the implementation, it's all there. If you want to look at adding a new device, or a new internal device or something like that, have a look at the source code and look how easy they are to implement. And you can send us a pull request or ask us some questions on how it might be achieved, and we'll help you out. There's about 100 issues on GPIO0. They're not all necessarily bugs. A lot of the things are just ideas that I've come up with and said, oh, we should do this. Write an issue. That's kind of how the whole GPIO0 project has been developed, just by myself and others coming up with ideas and putting them in as issues and driving the development in that way, which has been really successful. So have a look through the issues as well and comment on some of those and see which ones you're interested in and what you'd like us to work on. There's lots of things planned, lots of things coming. We're hoping to get another release out soon with a few minor fixes and some new things included. But there's a lot more on the sort of backlog and the wish list of features we'd like to see in the future. More GPIO devices, more support for things natively. I mean, currently, if you have a device that doesn't, it's a normal GPIO device that doesn't have its own class, for instance, it might just be a case that you can use the lower level parts of GPIO0 to manipulate the pins, and you still get the benefit of all the source values and all the remote pins and things. But perhaps it will be an easy step from there to implement a full native GPIO class for your particular device. device. We like to have more protocols and look at I2C and one wire, things like that, and constantly improve the documentation. There's a lot of work going into things like explaining how you can set up remote GPIO and how you can use that. I'm working on at the moment. And it'd be really cool to see, make it as easy as possible for people to just plug in their Pi Zero and use on-the-go, USB on-the-go mode. Some of these advanced features, I'd really like to see more people using those and try and help people. It's kind of a learning curve, like this progression from using LED.on, LED.off, LED.blink, connecting up buttons and working your way up towards some of the advanced features and building some really cool projects. We're still working with very little amount of code. It'd be really cool to look at a GUI representation of pins, so you can actually test things out and see them on screen, so using mock pin for instance, but actually see for real the pins changing in that sense. In the next version we'll have a pin out command line tool, so you can type pin out at the command line and you'll get an ASCII diagram of the Pi that you're on. So whether you're on a Pi, that's a Pi 3, that's a Pi 0, with all the information about what's on your Pi and the USB ports, whether it's got Wi-Fi, Bluetooth, or whatever else it's got, and then it'll actually give you a pin out diagram. And it looks at the revision code of your Pi and works out what it should show you, which is pretty really cool. Handy little tool showing you the pin out and some other things, which will be out in the next version. How we're going to read the docs, so there's a full set of documentation, not just API documentation, but recipes and examples of different projects that people have come up with. It's definitely worth taking a look. So I just wanted to thank the contributors at this point. The core team is kind of made up of myself, a guy called Dave Jones, who also maintains the Pi camera library, and Andrew Scheller is in the room, I think, somewhere. If it's away, there's Andrew. Don't mind the copy. It's some great work. And a bunch of other people have contributed to really important things, whether it's documentation fixes or additional components or helped us fix things. Some really, really key contributions there. I'm really grateful to people for what they've managed to throw in. If you managed to pick up this month's copy of the Magpie, 55, there's an article explaining source values and how you can build projects explaining logic gates, which is an idea that I credit to Miles Berry, but we had a chat about something and I came up with that idea. So do take a look at that, and go and speak to Russell about the GPIO 0 book. So in the Essentials, the Magpie Essentials range, we have a simple electronics for GPIO 0 book. It's full of projects and lots of API documentation in there as well. That's all. Thank you very much. I should think so. I'll check. Dave?
So what's the default backend?
Oh, Patrick, yeah. Anyone else? Is that Amy?
Yeah. If the whole point of the library is to make it more intuitive for people to go and get involved, how can you use negate instead of opposite or inverse?
Guess we didn't have you on the... Yep. So, GPIO 0 is a Python library, and I've encouraged people who work in other languages to, when they're designing GPIO libraries, that they take this kind of ethos and this way of this kind of design. So there's a JavaScript library, so called JS GPIO 0, which has taken the same kind of approach. So a lot of the libraries you find, if you use any other programming language and you're doing GPIO, it's always going to be a low-level library. So it's about pins, turning pins high and low, and using falling and rising edges and things like that. So it's down to the people who make libraries for the languages to take an approach like this that'll make it easier for them to use. So currently it's just Python. I think the JavaScript one is in development, but it's much more the stage that it is at the moment. Anyone else? We'll take another question. Tom?
Do you feel that by making things really abstract, you're preventing students from learning the kind of actually how an LED or a button works at an electronic level? Obviously, they get to a position where it works faster, but what does it? Do they know as much?
Yes. So what I'm aiming for is to make it easier to build projects and to do things for making. And learning electronics shouldn't be a barrier to turning your ideas into reality. That's kind of what I'm aiming for. And if people want to use it to teach electronics, it's probably a good starter, and then they can look under the hood and see what's going on. But it's really about making code readable and easy to write, and to be able to prototype quickly, put your ideas into reality.